Welcome. In this video, I'm going to use Euler's method to solve a differential equation. So Euler's method is a numerical. It's used to get a numerical approximation to a solution of a differential equation. So whenever you want to use Euler's method, you're going to be given three things. The first thing, you're going to be given y prime, or you're going to be given dy dx, or you have to solve for dy dx or y prime. And then that y prime is going to have a function called x in terms of x and y. So this is needed for Euler's method. You're also going to be given something called h, which is the step size of xn for the algorithm, for Euler's method algorithm. So for every iteration, you're going to add this step size to your x value for the previous iteration. And then thirdly, you're going to be given a start point. So that's going to be given in terms of x naught and y naught. All right. So these three things are needed in order to use Euler's method. Since this is a numerical approximation, you're going to be given each iteration is based on the previous iteration. Your previous x naught and your previous xn minus 1 and your previous yn minus 1. So for example, if you want to find for example the iteration yn is going to be yn minus 1, your previous solution from the previous iteration, plus h times the value of the function when you plug in your previous xn minus 1 and yn minus 1. So this is the general iteration for this method. Okay, so for example, your h here is here. Your previous is, you're gonna start here, so y1 is gonna start with this here, and then your fx, of course, is gonna be here, and that's gonna be given. So let's look at one example. Okay, so one example we're going to talk about today is going to be y prime is equal to your dy dx is going to be equal to y minus 2x. So let's gather our information that we need. So this is your f, big F, and then x in terms of x and y, and that's going to be equal to y minus 2x. Then you're going to be given an h, a step size. So I'm going to give you h is equal to 0.01. So you're going to start with this. And then your start point is going to be x naught and y naught, which is going to be equal to x naught equal to 0, and then y naught equal to 1. All right, so let's create sort of like a table. Okay, so your x's are gonna be here, your xn, and then your yn. Let's make it that yn a little here. All right. Okay, so your x naught is of course the start point 0, and then your y naught is gonna be 1. Then the next iteration, the first iteration, is gonna be x1. It's gonna be 0 plus 0.1, which is your step size, so it's gonna be 0.01. Your second iteration, your x2 is gonna be 0.1 plus 0.01, which is 0.02. And then your x3 is gonna be 0.03. Okay, y1, what's important, what we're looking after. So that's gonna be based on y naught. So y naught, what is y naught? 1. 1 plus your step size 0.01 times, we plug in your x, the initial x, so that will be 1 minus 2 times 0, and that's gonna give you, if you do it on the calculator, that's gonna give you 1.01. So your solution to your differential equation on the first iteration is 1.01. Your second iteration is gonna look like this. y2 is gonna be equal to 1.01 plus 0.01, which is your step size, and then your previous y, which is 1.01 minus 2 times your previous x, which is 0.01, and that's gonna be give you, if you do it on the calculator, it's gonna be 1.0199. And then the final thing that we want an n of 3. So 3 iterations. I'm gonna do 3 iterations. Oh, so I said that you need to have those 3, but and then this can keep going, and you're gonna be getting a better approximation. But for this example, I just wanna go to 3 iterations. So let's start with n equals 3. So just your size, just the number of iterations I'm going to stop. Okay, so y3 is going to be equal to your previous, which is 1.0199 plus 1.0199 minus 2 times your previous, which is 0.02, and that's going to give you the final answer, which is 1.029699. So that's what we want. Well, that's what we're looking at. 1.209699. That's gonna be our final n, which is the third iteration. In this example, you can keep going, but this is what I just wanted to show you how to use Euler's method. Thank you very much. Don't forget to subscribe to my YouTube videos. Thank you very much.